Classification of chemical reactions. For this worksheet, you're going to label all of these equations as synthesis, decomposition, single replacement, or double replacement. To know which type it is, you're going to look at your reading material. So here are the different types of reactions in your reading. So first, let's start by looking at synthesis reactions. In a synthesis reaction, we're going to have things come together to make something else. So it says here that a synthesis reaction, to synthesize means to put together or combine. So we're going to take two simple substances and combine them into one. So here's an example, H2 plus O2 yields 2H2O. This isn't balanced, but the idea is here. I take two simple substances and make one substance out of it. CaO plus H2O yields CaOH2. Two substances become one. I have put them together. Or in the pictures you can see I have a cat and a fish. You put those two together and you have a fish in a cat. Alright, so we have one thing at the end combined together that started with two. A decomposition reaction starts off as one thing and becomes more than one, because to decompose means to break apart. So it's the opposite of a synthesis reaction. Up here we had two different things becoming one, now we have one thing becoming two. So again, here's the opposite of that unbalanced reaction we saw earlier. We have two H2Os becoming H2 and O2. One thing becoming two. A chicken in an egg becoming an egg and a chicken. Alright, so separates out in a decomposition and comes together in synthesis. Then for single replacement, it looks like so. Single replacement means that one thing will be replaced in a compound. So we always start off with, usually it's an element in a compound. Now in this case we have a polyatomic ion taking the place of an element in a compound, but most of the time you're going to see one element and a compound. One element and a compound. So a nonmetal will replace another nonmetal. A metal will replace a metal. This is the most common type of single replacement reaction. And then you can sometimes have a metal replacing hydrogen. And here's an example of that. Zinc is a metal. It's going to go in and replace hydrogen. Hydrogen is bonded with chlorine right now. So it's going to kick out hydrogen, and zinc will then bond with chlorine instead, leaving hydrogen on its own. So you can see here we end up with zinc chloride, and then hydrogen got kicked out on its own. Now it's not just H, it's H2, because hydrogen is a diatomic. So when you do these yourselves, when you're making these reactions, you will have to make sure you pay attention to your diatomic elements. So here, silver goes in and replaces the metal sodium, so that now silver is reacting with chlorine. So we have silver combined with chlorine, and sodium gets kicked out on its own. It's not a diatomic, so we leave it as Na. So in the picture example, we have a dog with a bone. He sees a steak. He'd rather have the steak, so the bone gets left behind and is replaced by the steak. So a single replacement reaction. In a double replacement reaction, two things are replacing each other. So you're never going to find in real life a bunny with a steak, but for the sake of making this argument work, we're going to have a bunny with a steak and a dog with a carrot. They obviously would rather have what the other one has, so they're going to trade off what they have, and our bunny ends up with the carrot and our dog ends up with the steak. We have two compounds, things that are bonded together, switching off what they're bonded with to become two different compounds. So start with two compounds, end with two compounds. And then here's an example, Na2SO4 and CaCl2 are going to react with each other. Ca and Na are going to switch places. So the positive ion, because positive one always comes first, switching with this positive ion. So Na and Ca switch places so that Ca is now bonding with SO4 instead of Na. So CaSO4. Now Na is bonding with Cl instead of Ca, and I end up with NaCl. So two compounds became two different compounds because two things replaced each other. So you will use that reading material, look back at it, to help you determine for numbers 1 through 10 whether these are synthesis, coming together, decomposition, breaking apart, single replacement, one element replacing another element in a compound, or double replacement, two elements in separate compounds replacing each other, and write those on the lines. If you do still have any questions on this one, please come ask.